Hello and welcome back to Having Fun Repairs. This is going to be a kid STEM project, one in which we'll build a lightsaber. Our magic word of the day is what, Ian?
Simple circuit.
That's right, simple circuit. And so Ian came home from school from STEM class with a plastic tube, a green light emitting diode, and a simple 3-volt lithium coin cell battery. And you can power a battery right off of, or an LED right off of a 3-volt battery, no problem, okay? And you see that the light is kind of traveling up this tube as well. Well, this is essentially a simple circuit where we have potential energy stored within this battery. We have our path in which current can flow because we have a path through our resistance. Our resistance would be with this LED, right? Mm-hmm. And then the LED itself is going to turn this potential energy, which becomes electrical energy, into light energy. But we're not going to make it as simple as this, mainly because I would like for us to be able to save the lifespan of this battery a bit by adding in a resistor into circuit. And then I've also bought for us a package of battery holders, basically a case that we can put this 3-volt battery into with an on-off switch for powering on and off our lightsaber. Now, before we get into actually building this lightsaber, we need to do a couple things, Ian. One, we need to take a current measurement between the battery and our LED to determine how much current is being drawn from the battery. Okay, so I've got the multimeter out and we have it set to DC amps, okay? And our lead moved over for taking the amp measurement. And we have to do that in series with our battery. So what we're going to do is we'll determine which is the negative lead. We found that. We'll bend the negative lead out of the way. And then I'm going to have to, well, we'll do it this way. I'll put the negative lead underneath the battery as such. Then we're going to take our negative lead of our ohm meter and the positive lead to the LED to determine how much current is being drawn. And we can see it right there on the multimeter. Maybe they can't. There's too much of a glare. Let's move this over. And we're getting, what is that? 8 or 9 milliamps? Yeah, about 8 milliamps. Slowly draining because we're draining the battery. But that's something that we need to record down. So let's write that down. 8 milliamps. And then from that we can determine what size resistor we need. So I got this cool app downloaded on my phone called ElectroDock, and in it we can do a calculation for the type of resistor or the amount of resistance we need in series to still provide a forward supply voltage to our LED for it to operate, but also save us on our battery life. So essentially what I can do is I can come in here and select up. We got a standard green 2.2 volt 10 milliamp type LED, okay? We were measuring 8 amps, but that's pretty close. We're supplying a 3-volt power supply via this battery, okay? Now we actually measured, what, 8 milliamps, not 10, so we can slightly adjust that. Yeah. All right? So, in order to supply enough forward voltage on our light emitting diode and save the battery without draining it too quickly, we will need a 100 ohm resistor, and for this we'll just probably use like a 1/4 watt or an 1/8 watt resistor. Okay, so what we need to do next is we need to actually draw our simple circuit on paper and then we will build it. How about that? Sound good?
Yeah.
Give everybody a thumbs up. Up there, buddy. Good job. You about ready to explain what we did, Ian? Yeah? Let's talk about what we did. Well, we made ourselves a diagram, right? And on here we put our supply, our power supply right here, right?
Yeah.
And we have our positive and negative. He keeps looking at the screen because we're recording. We also marked the what side of our lead?
The
Negative side of our lead, right? So we don't confuse it with the positive side, right? So the positive side of our lead goes to this switch that's physically on here, and then the positive side will go to this 100 ohm resistor, and then with our LED we marked the negative side of it so we're not confused what's negative and what's positive. The positive side of our LED will go to the other side of our resistor, and then the negative side of our switch over here will go to the negative side of our LED. And for clarification, we write that as the anode side of our light emitting diode. That's the positive side that needs that. It needs to be oriented in the circuit that way. And then the cathode side is where our negative path goes to. Okay? So pretty simple circuit. And once we have this circuit completed, we have a path for electrons to flow, and then we take the potential energy in our battery into electrical energy through this circuit, and then turn it into light emitting energy from our LED. And we'll do something else when we finish. We'll take a measurement across the battery. We'll see that it measures 3 volts, but then we're going to take a measurement from battery to resistor, and then resistor over diode, so you can see that voltage drop as it goes through the diode. And I bet you we can add these 2 voltages here and here together to get the entire voltage for 3 volts. Ian just told me as soon as I cut off the video. Can you tell them, Ian? Tell them what you learned in STEM.
That when the flashlight is turned off, the energy that it's producing, it can't jump over.
So can't jump over the switch, correct?
And when you turn the flashlight on, it keeps going to the battery and goes around and around and again.
So you have a continuous path of just on here, like here. That's very good. I'm glad you're taking STEM classes, bud. Let's get to building our lightsaber, okay?
Yeah.
Okay, so I've got our materials out, not just materials that we need to build, but a hot glue gun, we're going to need that. A soldering iron, we're going to need this as well. So I highly encourage, if you're working on this, that you supervise or you do some of the work for your kids, because obviously these devices produce a lot of heat and can burn, can't they, Ian?
Yeah.
Yeah. We have some solder. This is 6040 lead tin solder. We have some rosin flux, right? Which is going to help us melt our solder and allow it to flow easier.
Yeah.
We have some diagonal cutters, right? So we can snip things.
Or you can call that tweezers.
Yeah, well, those cut. Tweezers are just used to hold. And then we have some heat shrink tubing right here that we can use to cover some of the exposed metal that's going to make our circuit. You know, this isn't high enough amperage that it's going to shock us at all, but we still want to be as extremely safe as possible when we build a circuit, don't we? Yeah. Okay, we've got our our lightsaber, for the most part, built. We still need to heat shrink these leads, that way they don't ever come in contact with each other. We keep it safe.
Or maybe come apart.
Yeah, but as you can see, it's working, right? Now, this was a 3-volt battery, wasn't it?
Yeah.
Well, I wonder how much, what's going to be our measurement across the entire thing? Let's check. Well, as you look at that, we're right there approximately at 3 volts. We're at 2.9 or whatever's remaining on the battery, right?
Yeah.
2.9. Now, I want us to measure, instead of through the entire circuit like we did like this, okay? I want us to measure from I want us to take a measurement through our resistor. Why don't we do that?
Yeah.
Okay. And what are we getting? 0.2 volts DC. And then when we measure across the LED, what are we getting? 2.6 volts DC. So we got that little bit of voltage drop, don't we?
Yeah.
Yeah. Now I bet we could actually put in a greater resistor and drop that down, that voltage down, to where we get 2.2 volts across our LED, which is really where we would want to be at.
Yeah.
I think. I don't know. But for now, I would say that this is good and it's going to save a little bit of our battery. So now we just need to button everything up. Y'all wouldn't have been able to tell via the video, but I did turn on our fume extractor, and because my son was helping me soldering, I decided it was probably best to put some safety glasses on him. Keep your eyes safe, right, Ian?
Yeah.
But now we can take this heat shrink tubing and we can shrink it down. You could use a lighter, or if you have a hot air gun,
Daddy,
which is what we'll be using, you could use that. What's up?
What if smoke goes in your eyes?
Well, that's why you wear those glasses.
If smoke goes in your nose, you just sneeze.
Yeah. And now last, Ian, because this is yours, I'd like to know your input. Do you want this glued to here like this so you can carry it like this?
Yeah.
Or do you want this just to stay like this?
I want it glued.
You want it glued? We can do that.
Maybe.
So what's the best side to glue it on? Probably this side over here, since this is the opening side.
Yeah, because you don't want to block the opening.
Yeah, so we'll glue it like this right here.
Yeah.
Okay? And then you'll have your lightsaber glued to here like this. And you can always just turn it off and on. Okay?
It looks like a Ghostbusters thing.
It kind of does, doesn't it?
When you might glue it to there, it looks like Ghostbusters thing.
Alright, let's get this thing glued up.
Yeah.
You ready, bud? Let's see if we can get it. Let's make some sound effects. Vroom, 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 vroom. Vroom, vroom, vroom. Zoom, 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 zoom. Zoom, zoom. You want to try it?
Yeah.
You do it. Do the sound effects too. It's your lightsaber. You're just staring at it glowing.
Mm-hmm.
Uh-huh. Well, Ian, do you think that was super cool?
Yeah.
Yeah? You like building that lightsaber? Yeah? You gonna go show your brother what it looks like in the dark?
Yeah.
Yeah? Why don't you give everybody a thumbs up? Tell them thank you for watching.
Thank you for watching.
Y'all take care. Goodbye.
Cool project, Daddy.
Thanks, bud.
Bark?